Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to sign up via the link in the description to get all of the lab files for this course, so you can try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better, and it includes over 100 guided labs to not only help you get hands-on practice configuring and troubleshooting, but also deepen your understanding of the exam topics. I used it myself when studying for my certifications, so I feel confident about recommending it to all of you. Watch until the end of this video. We'll take a look at a lab from NetSim. If you want to get your own copy of NetSim, please follow the link in the video description. In this lab, we will configure floating static routes. As I explained in the lecture video, floating static routes are configured just like regular static routes, except you set a higher administrative distance value, so that the route is less preferred than a route learned by a dynamic routing protocol. So although static routes by default have an administrative distance of 5, lower than any dynamic routing protocol, we can make it function as a backup route by making the AD higher. In this network, Enterprise A has two LANs, 10.0.1.0/24 connected to R1, and 10.0.2.0/24 connected to R2, and R1 and R2 are directly connected by fiber optic cabling. R1 and R2 each have two internet connections, one to ISP A with SPR1 and SPR2, meaning Service Provider Router 1 and 2. Also a connection to ISP B. Here are ISP B R1 and R2. In this lab, we are going to configure floating static routes on R1 and R2 to act as backup routes to allow R1 to reach R2 via ISP A, even if the direct connection between R1 and R2 fails. So the first step is to check the routing tables of R1 and R2. I'll check on R1 first. Enable Show IP Route. So we have connected and local routes for each of R1's interfaces. A static default route pointing to 203.0.113.9, which is ISP B R1, and a route to 10.0.2.0/24, learned via R2. Which routing protocol was used to learn this route? This O here means OSPF, as you can see in the legend up here. So Enterprise A is using OSPF as their IGP, Interior Gateway Protocol. OSPF is by far the most common choice these days, which is why it was selected by Cisco as the only dynamic routing protocol you need to learn in depth for the new CCNA. Now, which route will be used if PC1 tries to access Server 1? Server 1's IP address is 10.0.2.1, so the most specific match is this one here to R2, the OSPF route. How about if PC1 tries to access the remote server 1.1.1.1 over the internet? This server isn't in the network diagram, by the way, but it's somewhere on the internet. Well, the only route that matches is the default route, so it will use the default route to ISP B. I will ping to test each of these, but first let's take a look at R2's routing table. Enable Show IP Route. So its route table is similar to R1's. Connected and local routes for its interfaces, a static default route to 203.0.113.13, which is ISP B R2, and an OSPF route to 10.0.1.0, learned via 10.0.0.1, which is R1. So if PC1 tries to ping Server 1, when Server 1 sends the ICMP echo reply message back to PC1, R2 will forward it to R1. It won't take the path via ISP A. Now let's go on PC1 and try those pings. So I will use simulation mode to view the path traffic takes. But first let me ping both Server 1 and 1.1.1.1 from PC1 to allow all of the devices in the path to complete the ARP process. First I'll ping Server 1. Ping 10.0.2.1. Okay, next I'll ping the remote server over the internet. Ping 1.1.1.1. Okay, looks good. Now I'll switch to simulation mode. And let's ping server 1. Ping 10.0.2.1. It goes to R1, R2, then server 1, which sends it back via R2, R1, and then it reaches PC1. Okay, I'll switch back to real-time mode and cancel the ping using Control-C. Next, I'll ping the remote router, once again in simulation mode. Ping 1.1.1.1. Okay, it goes to R1, matches the default route on R1, and is sent to ISPB R1, which sends it back to R1, then PC1. I said 1.1.1.1 is a server somewhere on the internet, but of course there is no real internet in Packet Tracer. 1.1.1.1 is just an internal interface on ISPB R1. It's called a loopback interface. I'll talk about loopback interfaces soon in the course, but let me quickly show you on ISPB R1. Enable Show IP Interface Brief. So I actually configured two loopback interfaces, loopback 0 and loopback 1, although I ended up only using one. Similar to the SVIs on a layer 3 switch, these loopback interfaces are not physical interfaces, but virtual interfaces inside of the router. They have multiple uses, which I will explain in a later video. But one convenient use is for labs like this, to simulate remote destination networks without actually having to set them up in the lab. So the remote server 1.1.1.1 isn't actually a server. It's just a virtual loopback address on ISPB R1. Okay, next for step 2, we are tasked with configuring floating static routes on R1 and R2 so that PC1 can reach server 1 if the link between R1 and R2 fails. So we will configure one floating static route each on R1 and R2, using ISP-A as an alternate path. Let's go on R1 first. Enter global config mode to configure the route. Conf-T. First, write the command as a normal static route. So, IP route, followed by the destination network and mask. So 10.0.2.0, 255.255.255.0, then the next hop address, which is the address of SPR1's G000 interface, so 203.0.113.1. Now I'll use the question mark. It says distance metric. The word metric might be a little confusing, because this isn't the metric that dynamic routing protocols use to select the best route to a destination. This is the AD, administrative distance. So, to make it a floating static route, we have to set the AD higher than the route learned via R2. If we don't do that, the static route will be selected instead of the OSPF route to enter the route table, which is not what we want. We want the OSPF route to be used by default, and this static route to be a backup. OSPF has an AD of 110, so let's go with 111. Now let's check the routing table. Do show IP route. Where's the static route we just configured? It's not here, because we set the AD higher than the OSPF route's 110. The OSPF route is selected instead of the static route. Okay, we aren't done. R2 still needs its floating route, or else the return traffic from server 1 to PC1 won't have a backup route if the link between R1 and R2 goes down. So let's configure that on R2. Conf-T, IP route 10.0.1.0, 255.255.255.0, and the next hop will be SPR2's G000 interface. So 203.0.113.5, and let's set the AD to 111 here as well. Okay, let's check the route table. Do show IP route. Just like on R1, the route doesn't appear yet. Now let's shut down R2's G020 interface and see if that changes. Interface G020. Shut down. Okay, now the OSPF route is invalid. It can no longer be used to reach 10.0.1.0/24. So let's check the route table and see if the floating static route was inserted into the table instead. Do show IP route. There it is. 10.0.1.0/24 via 203.0.113.5. And here you can see the AD of 111. Let's go back on R1 and check. Do show IP route. Okay, same on R1. The floating static route now appears in the route table. So let's try that ping from PC1 to server 1 again. Once again, I will first ping in real-time mode so that ARP can complete. With this new route, R1, SPR1, SPR2, and R2 will have to use ARP again. Okay, let's ping. Ping 10.0.2.1. Now here's a cool packet tracer trick. Click this button here to fast forward 30 seconds in the simulation, to the point that the ping is complete. If your ping still hasn't gone through, try the ping again and fast forward again, like this. The pings are going through, so ARP is complete. Now let's switch to simulation mode and ping again. Ping 10.0.2.1. Looks like the floating static route is working. The ping to server 1 now uses the backup path via ISP-A, and the return traffic does the same. Before finishing this lab, I'm going to switch back to real-time mode and show you another useful tool to check the path traffic takes. In a real network, you can't just turn on simulation mode like in Packet Tracer to see the path traffic takes. Instead, you can use the traceroute tool. In Cisco iOS, the command is traceroute, spelled out like this. However, on a Windows PC, it's traceRT, then the destination IP address, which is 10.0.2.1. There it is. So what does traceroute do? It's like a ping, except every layer 3 hop along the route to the destination sends a message back to the source. First is 10.0.1.254, R1's G01 interface. Next, 203.0.113.1, SPR1's G000 interface. Then 192.168.1.2, SPR2's G010 interface. Then 203.0.113.6, R2's G000 interface. And finally, the reply from 10.0.2.1, server 1. Traceroute is a very useful tool for troubleshooting and making sure traffic is following the intended path. Make sure you're aware of it for the exam, and try it out in Packet Tracer labs. Okay, that's all for this lab. Next, let's take a look at a practice lab from Boson NetSim. Okay, for today's Boson NetSim practice lab, we're doing static routes 2. So there are some OSPF configuration labs in Boson NetSim, but we haven't covered configuration of OSPF yet, so let's do some static routing. Here's the lab objective. Build a lab network to test new configurations that will be rolled out to a production network. Configure router 1 and router 2 with static routes so that all devices can ping any other device. Okay, so pretty simple lab topology here. Host A and host B with router 1 and router 2. And what's this? S00. This is a serial connection. So I haven't covered serial connections in the course. That's because they have been removed from the exam topics list. So I think you probably won't get any direct questions about serial interfaces on the CCNA, but I still think it's good to know, so we'll cover some basic things here. One of those basic things here is the clock rate command to set the essentially the speed of the serial interface. Okay, these are other commands you need to know. These ipconfig commands are for the NetSim PCs here, host A and host B. This command sets the IP address, and this one, ipconfig/dg, sets the default gateway address of the PC. So that would be probably router 1 for host A and router 2 for host B. Okay, here are the IP address charts for each device and the lab tasks. So let's get started on task 1. Configure router 1 with a host name of router 1. Okay, well, we're already in the CLI of router 1 here. It's open by default. Enable conft host name router 1. Okay. Next, configure the appropriate IP addresses on the interfaces. Refer to the IP addresses table. Okay, let's do that next. So interface fast Ethernet 00. The IP address is 192.168.101.1/24 mask. enable the interfaces. It says right at the end of here, so I'll just do that. No shutdown. Okay, next one, interface serial 00, IP address 192.168.1.1/24 mask, no shutdown. Now this part here, a DCE cable is connected to router 1. The serial link should have a speed of 64 kilobits per second. So this DCE is a concept in serial connections. One side is DCE, the other side is DTE. And the DCE side has to set the clock rate. So we'll use this clock rate command to set a speed of 64 kilobits per second. Clock rate, here are the options. So we're looking for 64,000. There we go. Okay, so that's step 1. On router 1, configure a static route so that all devices can ping any other device. Okay, so router 1 has these two connected networks, 192.168.101.0/24 and 192.168.1.0/24. So the only network it needs a route to is this network here, 192.168.100.0/24. We could configure this as a default route, but it doesn't specify that, so let's configure just a route to that subnet. IP route 192.168.100.0/24 subnet mask, and the next hop will be router 2's serial 00 interface. Okay, let's check. Do show IP route. Oh, right, it's not up yet because this interface is still down. Okay, and then we do the same things on router 2, it seems. Yes, except on router 2 side, we do not need to configure the clock rate command because it said router 1 is the DCE side, router 2 is the DTE side. So it will receive the clock rate from router 1. So let's go into the CLI of router 2. Click on router 2 here, then console, enable conft hostname router 2, and then the IP addresses. So interface F00 100.1 with /24. Enable it. Interface serial 00. IP address 192.168.1.2. Again /24. No shut. Okay, I think that's all we have to do for this step. Yes, okay, and next another static route, this time on R2. So we'll configure it to this subnet here. Exit IP route 192.168.101.0, 255.255.255.0, and the next hop is router 1 serial 00 interface, 192.168.1.1. Okay, now if I check the routing table on router 2, it should appear this time because these interfaces are both up now. Do show IP route. There it is, okay? So connected routes and the static route. And if we check once more on R1, now they appear. Okay. So that is up to step 4. Okay, next step 5, host A and host B. So let's get into the CLI here, host A and host B. So what was it? Configure the IP addresses and default gateway. Okay. So host A, let's check first. ipconfig/all does not have an IP address. And here are the commands we need to use. So first, to set the IP address, ipconfig/IP address mask. Let's do that. ipconfig 192.168.101.2 255.255.255.0. And I forgot the /IP. Okay, and next the default gateway, ipconfig/DG, and that would be this address here on router 1, 192.168.101.1. And let's check ipconfig/all. There's the IP address, subnet mask, and default gateway. Looks good. Next on host B. First, check if there are any configurations. Nope, all 0000. So ipconfig /IP 192.168.100.2/24mask and set the default gateway. That is this address on router 2. Okay, on router 1 and router 2 display the routing table. Oh, we already did that. I'll just do it one more time. There they are. You can see the static routes we configured. Yep, same here. And verify your configuration by pinging from host A to host B, 192.168.100.2. Okay. Let's hope it works. Okay, looks good. Pings are going through. Okay, so this time we actually did the entire lab. So let's see if we did the correct configurations. Once you have completed this lab, be sure to check your work by using the grading function. You can do that by clicking here, Grade Lab. Okay, let's see if we did it correctly. And we did. You completed the lab successfully. Click OK to view the results for the individual devices. So this is the correct configuration. If we were missing commands, they would be highlighted in red here. If we had extra commands that we didn't need, they would be in blue. So, all white here, so looks good. Okay, and if you ever have any trouble during the lab, or even after you finish and you want to read some explanations, which I really recommend you do, check the lab solutions here. They give you step-by-step walkthroughs of the lab, and some in-detail explanations. Okay, so that's Boson NetSim for CCNA. If you can, I highly recommend picking up a copy. There are over 100 guided labs covering all the exam topics in the CCNA, and it's just a really great practice resource for the CCNA. So if you want to get a copy, please follow the link in the video description. Before ending this video, I want to take a minute to thank my JCNP level channel members. Thank you to Magrathia, Justin, John, Funny Dart, Joshua, Scott, Alexa, Hassan, Gerard, TB, Vikram, Joyce, Marek, Samil, Velvijakum, C-Mode, Johan, Mark, Miguel, Yusuf, Koni, Boson Software, the creators of NetSim, CD, Devin, Charlesetta, Lito, Jonathan, Mike, Alexander, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. These are my JCNP level channel members as of June 20th, 2020, by the way. If you joined recently but your name isn't on the list, don't worry, you'll be in future videos. Thanks again. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.